Okay, this is our last lesson, 7.6. However, this might be our longest lesson, so bear with me. So we have to show that this equation is indeed a parabola. You have to prove it algebraically. The way to do that is to get this equation in this form. So we're going to be basically completing the square to get that equation in the vertex form that we learned. So first and foremost, I want to go ahead and, instead of g of x, write y. X squared minus 12x plus 7. I'm going to move the 7 over to the other side. Minus 7 is equal to 3x squared minus 12x. We know that before we can complete the square, the number in front of x squared can't be there. So I'm not going to divide everything by 3 because that is going to be a mess. I'm just going to pull it out. I'm going to pretend like it is my greatest common factor. I'm going to leave some space to complete the square. So instead of 3x squared, it just is x squared, and then this is minus 4x. Again, leaving some space to complete the square. So if you remember, it's that middle term b divided by 2 quantity squared. So when you divide by 2, you're there. When you square it, you get 4. So I'm adding 4 to this side, but be careful. I'm not just adding 4 to the other side, because outside of the parentheses right here is a 3. So I'm not adding 4 to the left side. I'm actually adding 4 times 3. I'm adding 12 to that side. That's the tricky part. If there's a number right here on the outside, you have to remember to multiply it. So I'm going to combine my like terms on this side, and I get 5. And then I know that's 3. And then inside my parentheses, when you factor that, you get x minus 2 quantity squared. And we just proved that this is indeed a parabola. So what we're going to do next is take that, and we're going to find the vertex and then sketch said parabola. So remember, the vertex you can just pull from the equation. If it's negative 2 in the equation, it's positive 2 in my vertex. If it's positive 5 in the equation, it's negative 2 in my vertex. So my vertex is 2, negative 3. Oh wait, negative 5. What am I thinking? 2, 3, 4. Right there. And this guy right here is positive, which means my graph is positive. It's happy. So when you draw it, oh, I want to do my vertex too. Not my vertex, my axis of symmetry. There we go. All right, and then when I draw my parabola, he's positive, facing up. Okay? Example 1, complete. Example 2, we have to find the vertex of this equation. So I'm going to rewrite it, because right now it looks crazy. Negative x squared plus 4x plus 3. So in order to find my vertex, I don't actually have to get it in the form that we've been using. There's a formula that helps you find your axis of symmetry, which then will in turn help you find your vertex. So to find your axis of symmetry, you can use this formula right here. Negative b all over 2a. Remember, the axis of symmetry is what cuts your parabola in half. Okay, so it tells you where it cuts. So to find the axis of symmetry of this guy, I need to know what b is and what a is. Well, a is negative 1, b is 4, c is 3, but that's not important. And you just go ahead and plug it in. So you have negative b, so that means we have negative 4 on top. And then we have negative 1, so that's on the bottom. And so you get negative 4 over negative 2, which means my axis of symmetry is 2. So that's where it cuts my parabola in half. The axis of symmetry is the first part of your vertex. So I need to figure out the second part. We figured out what x is, I want to know what y is. Well, to do that, you just plug 2 into your formula. So y is equal to, instead of x, it's 2. So I'm just replacing all my x's with a 2. That's a plus sign. So this is -4, that's plus 8, that's plus 3. When you add those together, you end up with 7. So that means my vertex is 2, 7. P.S. That formula needs to be memorized. Okay? So that's part 1 of this problem. Part 2 is finding the domain and the range. So what I want to do first, just to kind of give you a visual, is let's graph this so we can talk about what the domain and range looks like. We just found out that the vertex is 2, 7. So I'm going to go ahead and plot that point so you get the visual. 1, 2, 3, 4, 5, 6, 7. Okay? And that's my axis of symmetry. The second thing we're going to talk about in sketching our parabola, is he a happy parabola or is he a sad parabola? Is he right side up or upside down? This guy's negative, so he's a sad parabola. So he's going down. Okay, so that's what our parabola looks like. Now let's talk about domain and range. So remember, domain is everything that x can be. And range is then everything that y ends up being. So think about this. Is there any number that I cannot plug in to this function? Is there any number that I couldn't plug in and get a point out on my x-axis? The answer is no. I can plug any number into this quadratic formula and it's going to work. So we have all real numbers for the domain. For the range, we have to think about what could our y be. Okay? So I want to think about our quadratic right here. Our vertex is the highest point on this graph. And we know that this vertex right here is 2, 7. My y right here is 7. Can I ever have y be 8, or y be 9, or y be 10, or y be 11, or 12? No. The highest my y is ever going to be is 7. That's the biggest it can be. So your range is going to be that y is less than or equal to 7. Because y right here can be 6, it can be 5, 4, 3, it can be in the negatives. However, it's never going to go higher than 7. So that's why y is less than or equal to 7. The last thing we need to do is find the zeros of the function. And so that just means, when it says find the zeros, that just means solve for x. There's a million ways that we can do this. We could complete the square. We could get it in the quadratic form, so we can just square root both sides. But I'm just going to go ahead and use the quadratic formula. I think that's the easiest way. Or it's just the quickest for me right now. But if you have another way you like to do it, then by golly, do it that way. All right, so x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Boom. So x is equal to negative 4 plus or minus. I'm going to go ahead and just add all that up. We get 28. And negative 2. This becomes negative 4, and then plus or minus, remember this is 4 and 7. So a 2 gets to come out, 7's got to stay underneath, negative 2 on the bottom. I want to divide everything by negative 2. Negative 4 divided by negative 2 is 2. And since this is plus or minus, it's just going to stay plus or minus. And these guys really just cancel each other out. So all you're left with is the square root of 7. So my zeros are 2 plus or minus 7. X is going to cross, or this parabola is going to cross the x-axis at those 2 points. Example number 3. Determine whether the function has a minimum or a maximum value, and then we are going to find it. So a minimum or maximum value. That's a minimum is the lowest point on a parabola. A maximum, if it's upside down, is the highest point on a parabola. So our parabola right here, we have to decide, is he going to be positive like this guy, or is he going to be negative like this guy? Is he going to be a happy parabola or a sad parabola? This one, the 4 is positive, so we know he's going to be happy. So that means this guy is our minimum. We're going to have a low point on our parabola. Okay? So that means we have to find it. The way we find the low point is we have to figure out our vertex. The minimum or the maximum is always your vertex. And the way we learned to do that is by using that axis of symmetry formula. I'm going to write it down again. Remember, it's got to be memorized. So we have negative b all over 2a. If you look back in the equation, b is 8, so we have negative 8. And then again, we look back in the equation, a is 4. So we end up with negative 8 all over 8. So our axis of symmetry is negative 1. That means we know x is equal to negative 1. If I was to graph this guy, oops, our axis, this is so terrible. Our axis of symmetry is negative 1 right there. So I want to figure out again the lowest or the highest point, so I need to figure out my vertex. I know half of it. I need to figure out what the other half is. So I'm going to plug him into plug this guy back into my equation. So y is equal to 4, and then in parentheses is negative 1 squared plus 8 times negative 1 minus 1. So negative 1 squared is 1, so we have 4 minus 8 minus 1. There we go. And when you add all those together, you get a negative 5. So I know my y is negative 5. Oops. So the lowest point on this, 1, 2, 3, I want to use a different color. 1, 2, 3, 4, 5. That would be your vertex right there. And then you would just graph it like that. Okay? Here are some hints for your homework. 3 and 6, get it into this form, then graph it. 9, 12, 15, 18, follow our first notes example. 21 and 24, follow our third notes example. 27 and 30, follow our second notes example. I'll work with you in class on Monday, and then our test is Tuesday.